The 5-number summary of a set of data consists of the minimum data value, the first quartile, the median, the third quartile, and the maximum data value. So again, if we're looking at our picture with all the quartiles, this is our 5-number summary that divides the data up into the 4 equal parts. So we start with the smallest data value, Q1, the median, Q3, and the largest data value. Here's an example. We had this sample of 20 employee commute times that we used in the last section, so we're going to find the 5-number summary for this sample. We already found that the median for this data is 17.5, the first quartile is 15, and the third quartile is 23.5. We also need the minimum and maximum values to get our 5-number summary. So the minimum value is 11 and the maximum value is 40. So our 5-number summary is 11, 15, 17.5, 23.5, and 40. And again, this is the minimum, Q1, the median, Q3, and the maximum. And remember, an easy way to get this, if you don't mind putting all these data values into your calculator, is to enter all of these into a list and then use one variable stats. It will give you the mean and the standard deviation as well as these 5 values if you keep scrolling down in that one variable stats screen. Here's a second example, and in this one we're going to use StatCrunch because there are so many data values it would be very time consuming to find the 5-number summary by hand. So we're going to look at the data set IQ samples in StatCrunch. It includes 3 different random samples of 120 IQ scores, and we're going to use one of the StatCrunch functions to find the 5-number summary for each of the 3 samples. So I'm going to StatCrunch, I'm in our class group, and I'm looking at all of the data sets, and we're looking for the one that says IQ samples. So there it is. So here are our 3 samples, and there are 120 values in each one. Now a really easy way to get the 5-number summary is to do stat, summary stats, and columns. And we're going to do this for all 3 samples, so we want to select all 3. So I'm highlighting sample A, and then you can either do a shift down arrow or you can do control click to get the other ones also. So I've got all 3 samples listed here. And here's the list of statistics that you can get StatCrunch to find for you. And they automatically have all of these highlighted. So let's just go ahead and leave that like it is. And here you can see the list of all the ones that we're going to get. There's some in there that we don't need, but that's okay. So I'm just going to go down to the bottom here and click on Compute. And it's giving me all of those statistics for the 3 samples. Notice we have the mean, the variance, the standard deviation. The standard error is something else that we don't need right now. But we also have the median, the min, the max, Q1, and Q3 for each of those samples. So now, if we want to, we can just copy. So I'm just highlighting that whole thing and doing a control copy, and then we can copy it back into our PowerPoint or into our homework, whatever we want to do. Okay, so back to our PowerPoint, and here are those values pasted into here. I did take out the one column that we don't have any use for right now, just to make it fit. But here are the values over here that we're really interested in right now. So to get our 5-number summaries For sample A, we're looking at the minimum data value, which is 50. Q1 is 84. The median is 97.5. Q3 is 106.5. And the maximum is 134. There's our 5-number summary. And we can do the same thing for the other 2 samples. And one nice thing about having them all like this is that we can actually do some comparison of the samples. Notice that sample A had the lowest minimum of any of them. Sample C had the highest maximum of any of them. And sample C also had a higher median than the other 2. Boxplot is also called a box and whisker graph, is a graph of a data set that uses the 5-number summary. The box part of the graph consists of a box with lines drawn at the first quartile, the median, and the third quartile. The whiskers are lines on either side of the box that extend to the minimum and maximum values that are not outliers. And when we're talking about outliers here, we're talking about the method of using the fences. Then for values outside of the fences, we use a special symbol, such as an asterisk, to identify those outliers. Here's an example. This box plot came from a data set with this 5-number summary: 60, 68, 74, 80, 124. So here's our box. This side is Q1, which is 68. This side is Q3, which is 80. And the line in the middle is the median, which is 74. Now the whiskers are these 2 lines that go out on either side. And again, to find where these lines end, we would figure out for this one we would figure out our lower fence. And then this line would extend to the smallest data value that's inside of that fence. On this side, we would figure out our upper fence, and the line extends to the largest data value that's inside of that fence. And these 2 dots out here represent outliers. So these are values that are larger than the upper fence over here. Now we can actually tell what those fences are because we have our quartiles. So the lower fence would be our first quartile, 68, minus 1.5 times the inner quartile range, which is Q3 minus Q1. So that would be 50. So our lower fence is actually all the way over here. Our minimum data value is 60, which we would know from looking at our 5-number summary. So the whisker just goes out to the 60. Now for our upper fence, we take Q3, which is 80, plus 1.5 times our inner quartile range, and we get 98. So our upper fence is about right here. Again, we can see from looking at our 5-number summary that we must have at least one data value that's larger than that. Now to tell exactly where this upper fence would extend to, we would have to have the entire list of data, because this is going to be the largest data value that's 98 or less, and we don't know exactly what that is without our entire list of data. But we do know that we're going to have at least one value that's an outlier, so is represented by a dot in this case out here. Actually, in this case, looking at the box plot, we had 2 outliers. Okay, box plots can help us determine the shape of the distribution. So here's one example where we have a histogram where the distribution is very obviously skewed to the right. And if we look at the box plot for that same data, we can identify, if we have the scales set up the same, we can identify the Q1, the Q3, the min, the max, and the median all on this graph. And notice in this box plot, the part of the box that goes from the median to Q3 is a little bit wider, and this whisker over here is longer. That connects with this histogram showing that it's skewed to the right. So both of these 2 things agree. If we look at this histogram, this data is skewed to the left. And again, if we look at the box plot, we have a wider part of the box that's on the left side, and our left whisker is longer. So both of these two agree that we would have a distribution that's skewed left. This one in the middle is very nicely symmetric, and the box plot is also very symmetric. Looks like we have the same distance between Q1 and the median as between the median and Q3, and the whiskers on either side look like they're the same length. So in both of these we would be able to see that we have a symmetric distribution. Now, it's not always this clear. These distribution shapes are all fairly obvious, but there are times when you can't really tell for sure from the histogram, and sometimes it's more obvious. Here's another example where the distribution shape isn't as obvious. So these box plots and histograms are for the 3 IQ samples in StatCrunch that we looked at in the last section. So we want to identify the distribution shape for each one if we can. So this first one on the left, from the histogram, isn't very obvious whether it's skewed to the right or skewed to the left or bell-shaped. But if we look at the box plot, notice that the left side of the box in the box plot is wider. So that would give us a clue that it might be skewed to the left. So this one, although it's not absolutely clear, is probably skewed to the left. Now the one in the middle from C, this one is more obviously skewed to the right because it has a longer tail on the right and more of the data is on the left side of the graph. If we look at the box plot, there also, the right part of the box is wider. There looks to be a little bit longer whisker on the right side also. So this one also from the box plot would be fairly obviously skewed to the right. Now finally, the last one on the right side here. This one, again, from looking at the histogram, you can't tell for sure that it's symmetric, but if you look at the box plot, it looks like the two sides of the box are about the same width. The two whiskers are about the same width. It does have an outlier out here on the right side. What we could tell from the box plot would be that it would be approximately symmetric.